presentation is Dr. Wei-Min Lee, who is the CTO of Leadmicro. Dr. Lee has a PhD in organic chemistry from University of Helsinki, Finland. He is actually internationally very well-known technology expert, and he's also an entrepreneur with more than 25 years of experience on research, development, industrialization, and commercialization of atomic layer deposition technology. Dr. Lee, it's really my pleasure to welcome you on board.
Hi, good morning or good evening, everyone. Hi, Joanna, thanks for your invitation. Can you see me well?
Yes.
All right,
yeah,
all right. Okay, great. So I will start to share my presentation. It's really, really nice to have this chance to present Leadmicro's technology to everyone, and hopefully we can have some opportunities to serve the solar market overseas as well. Okay, you can see my presentation, right?
Yes, but probably you have to go into the presentation mode.
Yes, okay.
Yeah.
All right, so today my talk is a smart ALD enabled PERC, and I will give a short introduction to Leadmicro, what we call it AEP product, which is ALD enabled photovoltaics technology. I'm Wei-Min Lee, services CTO in Leadmicro. So many of you have seen this chart, I suppose, and this is ITR PV last year's a roadmap. What you can see is that the message is that no matter you are working on the PERC, other type of PERC related technology include the PERC and Topcon and so on. So the market is going to be dominant in the next few years. And through this trend, whatever this cell technology is, and one important trend which I'm very much agree upon is that ALD will be gradually earning its market share. From the right-hand side, this slide, you can see it very well. So through this technology roadmap, you can see ALD is actually replacing PECVD as a mainstream technology for passivation. And probably for, I would add a comment, it's maybe not only for passivation in the future, maybe some other new applications as well, but all these are for high efficiency solar cells. And Leadmicro is a real well recognized as a pioneer for batch type of ALD technology. So we are quite a young company, but we entered PV industry by our innovative batch ALD. And so we're quite proud. In the PV magazine in 2019, it had pretty well emphasized that the ALD stormed market for PERC. So as PV magazine quoted, technology made in China is reshaping the market for industry equipment to produce state-of-the-art photovoltaic cells. And immediately after the June edition, the August edition has a question on whether ALD and the PECVD, and they do recognize that the Leadmicro is a pioneer on this batch ALD for PERC manufacturing. Not only in the PV industry, but actually in the ALD technology field, Leadmicro's innovative way of making this successfully, this ALD batch type of reactor is also well recognized. So from this University of Eindhoven, Professor Erwin Kessel, who received the ALD award in 2019 in his plenary session, he had especially very proud say that ALD is really big in the solar industry. So that's we're quite proud of that. And of course, in China PV market, we are also very well recognized because of our contribution and innovation to the China's PV industry. There are some most influential equipment enterprise and so on, smart manufacturing enterprise. So so we are aware of this. Our technology can bring values to the market. So in this page, I would like to just to give everyone a heads up on how the batch ALD is developed. So Leadmicro established only in 2015, but in 2016, we used less than a year. We developed the first generation ALD batch ALD system. We call it KF 4500, which means that time the throughput is already a world record throughput, which is very high. And throughout the years, almost every year, we keep the either efficiency record or throughput record. And last year, we rolled out the production tool with the throughput capacity is already 15,000 wafers per hour. And obviously, everyone has noticed already that in China, the industry is gradually shifting to Topcon technology. And what we have seen in some of these Topcon lines, the efficiency is already over 24.5%, close to 25% in this volume production. And basically, so far, we used about 5 years. We have gained almost all the major production customers uses our batch ALD, and our development is really fast because we have such kind of high capacity. Within 5 years, we delivered more than 100 gigawatts capacities, and that is not easy to do. Okay, so I just to give a very short introduction on the ALD, because my previous speaker already mentioned something already, Mr. Zhang Dan. So I won't repeat details, but I think I like to highlight there are 4 important features. One is indeed ALD is a high density pinhole free thin film that's suitable for passivation. And also ALD can precisely control the film thickness. Either you have 1 nanometer or 3 nanometer or 10 nanometer, it's digitally controlled. And the third is it has excellent conformality, which in terms of front side passivation, for example, currently used the Topcon, you probably will have to use ALD. This is also why in the N-type cells passivation, ALD is mostly used. And with our batch systems, we have also a very important feature is that it allows you to use novel materials and even laminate materials. This is, I see it's very important for next generation cell technology. So throughout these years, I often in the conference, people ask whether to choose ALD, PALD, and PECVD. So I like to just briefly touch on that, why we are sticked on the ALD process and the equipment. So first, obviously, I think compared to 5 years ago, today it's already very self-evident that ALD has actually a better passivation properties compared to PECVD. And in these two charts, it is our collaboration partner from University of New South Wales. It's Professor Bram Hawks. They have studied in detail to compare CVD and ALD, for example, carrier lifetimes. It's very clear that ALD within, with given the thickness, ultra thin ALD films, for example, 3 nanometer or 5 nanometer, it is very clear that ALD has indeed better passivation properties in terms of interface defect density and higher negative fixed charge density. So that's theoretically, it should be good, better ones. And practically, of course, we have over 100 gigawatts in production. We have a lot of opportunities to directly compare apple to apple with the efficiency. And we do see in production lines that ALD does have a higher efficiency. And in some cases, compared to PECVD, the efficiency error might be even 0.1 to 0.2%. And that is a lot when you are grading your cells, and each of these 0.1% is one level of your cell output. So for the PERC, in these two charts, I happily show to everyone is that we collected during the past 5 years how ALD progressed in the PERC production. For example, for the left-hand side, compared to the traditional BSF cells, when PERC starts, the efficiency jumped over 1%. But when we started the ALD with the water process, we see that there are efficiency gains, further efficiency gains with compared to PECVD. And this is one very good and also Leadmicro's innovative process that we switched water to ozone process, and that gained even more efficiency. And of course, nowadays, most of the PERC lines are what we call PERC Plus. So with the PERC Plus lines, we also see that ALD has more advantage over PECVD, so-called 2-in-1 or whatever this type of technology wrote. So especially with the alkaline polish introduced into the production line, and we see that the ALD does has some advantages in efficiency gain. And another reason is the high yield. I remember a few years ago when our batch ALD just entered market, which made a lot of notice. There are some scholars has argued that because you have a ALD system, you still have to have a separate capping silicon nitride step. So in between, there is wafer transfer. So the yield may not be as high as 2-in-1. But after 5-6 years in production, what we see the result, it's actually quite clear, or even surprisingly, we see the surprising result. In fact, the ALD has a better yield compared to typically PECVD 2-in-1. So we actually have one PhD student, especially doing this type of study. And today I can share a little bit. our initial finding. So why in production line, two separate step with the ALD has a better yield compared to 2-in-1. One of the important contribution, what we think through our study, is that ALD is intrinsically has a good uniformity. Even like in this case, in this table, what I showed you, ALD's typical uniformity is 3%. And especially with the batch-to-batch variation, it's very small, it's very stable. But we also tested PECVD, and the uniformity is within wafer uniformity and wafer-to-wafer uniformity is much worse, especially when you are thinking that the aluminum oxide, you probably need 3 to 10 nanometers. So in such kind of thin thickness, uniformity plays very important role. So I think this is one of these major contribution, because ALD has better uniformity on the cell, and also process reproducibility is best. So now come back to those scholars' argument that because it's two-step, mechanical loss will be good. But actually, currently, everyone knows in the production, the mechanical cost wafer loss is like less than 0.02%, which is 0.2 premium. So this is already insignificant compared to how much A-grade cells you can get. So that's why we see our initial study shows that the ALD, because of this intrinsic uniformities and the reproducibility, it has a high yield, and that is significant after 5 years running in production. So also the low cost of ownership, that is through the 5 years long-term production monitoring. I cannot share exactly the data because quite sensitive, but it's quite safe to say that ALD plus a silicon nitride, the overall cost is lowest currently. With the batch ALD, there is also some drawbacks. In fact, in this case, it's a footprint because you have additional ALD tools in your factory, so you will have a little bit more space needed. But all this is not hindering the lowest cost of ownership. That's also important for the production. And there are actually, through the years, we found some additional benefits of using ALD. First is that we have found that there are some studies to show that there is improved cell reliability. There are a lot of talk, especially from the research field, for example, light and temperature-induced damage because of the P-type cell. And because ALD has the dense film, and it is intrinsically, the film has high hydrogen lean, has a very little hydrogen in the film, so it helps to reduce this what we call it LETID problems. In terms of PECVD, because it's a plasma assisted, there are lots of hydrocarbons there. So it is, I think this research result looks reasonable. And we also have done quite a lot of research on material development and process development. I think in the future, even for PERC, we have some novel solutions, and that may fundamentally improve the PID of your modules. So if someone is interested in more details, you can refer to some presentation and publication materials, what we have made together with University of New South Wales back in 2019. I think that is also a very important feature for ALD. Last but not least is that I think it's also a very important one is ALD has application extendability. So when you look at the solar cell technology from the PERC to PERT, Topcon, HJT, and what we call it XBC, IBC type of cells, even to the tandem cells, all of these will require thin functional films. For example, in Topcon, currently we are mostly focused on. So the front side passivation, you need we use the ALD aluminum oxide because you have to use it because of the front side texturing. But in the back side, you need only 1 nanometer or even less silicon oxide, tunnel oxide, and this can be achieved in ALD. That is a significant importance. So Leadmicro currently marketing and provide smart atomic ALD-enabled photovoltaic turnkey solutions for high-efficiency solar cells. For example, we have provided world first turnkey solution Topcon lines to Suntech. Maybe if people notice the news, you will notice that this is the world first turnkey Topcon lines, what we provided with the 2 gigawatts. And why? Because I think that the future high efficiency solar cell manufacturing, it's not anymore with a lot of labors, because our tool, for example, our batch tool is throughput, newest edition is 20,000 wafers per hour. You cannot possibly manage this kind of production with the manual labor to do that. So we see the clear trend. Solar industry is going to the unmanned factories, intelligent navigation systems with the out-guided vehicles, with the intelligent diagnosed and mass-controlled systems for production. I just give a brief introduction of our product portfolio. We have a batch ALD called Quafu series, and we have also PEALD, which is our Leadmicro's innovation, PEALD 2-in-1, which is doing PEALD aluminum oxide and PECVD silicon nitride. That is a Zhurong series. And we also have our new edition of Xihe series, which is low pressure equipment tools. It has a multifunction, include diffusion, anneal, oxidation, as well as LPCVD. They are all targeted to the PERC and Topcon and IBC. I think for the individual, I will very quickly go through. I don't go to details individual systems. For example, KF series is currently largest. We have the highest market share of the ALD systems shipped worldwide, and with the highest throughput in the market. We currently offers 20,000 wafers per hour throughput to these KF systems. And the Zhurong series is our innovative PEALD PECVD 2-in-1 that is dedicated for PERC, but it can be converted to Topcon easily, switch the process to PEALD silicon oxide, tunnel oxide, and polysilicon. This is our innovation, and it's very hot in the market. And our newest addition is our modular designed low pressure system, which is called Xihe series. It offers both phosphor diffusion as well as boron diffusion, and it can be converted to LPCVD to do the poly deposition as well. Okay, I quickly go through this our smart AEP products. So we offer worldwide our atomic ALD enabled photovoltaic for PERC. We actually have a couple of very good example project, which is running running over 23% of the conversion efficiency production lines currently in China. So start from texturing until the printing and firing. This is we partner with our sister companies to offer the PV industry the complete solution, and we can guarantee the efficiency. And everyone familiar to the Chinese Topcon market development will notice we deliver this AEP Topcon products to Suntech as well as Tongwei. These currently are ramping up the production at the moment. And this is just some of these examples on how we deliver these systems from the PERC to Topcon. Leadmicro is a new company. We have our business covers semiconductor, photovoltaic, lithium-ion battery, and fuel cells, as well as flexible electronics. And our core technology is ALD. We do mostly the ALD-related equipment. Let me conclude my presentation by quote Professor Erwin Kessel, who is a professor in the Eindhoven Technical University, and he is also the ALD award winner in International ALD Conference 2019. I would like to conclude it so that he said, ALD has made its mark in photovoltaics, and the further we creep towards the efficiency limit, the more the atomic level of control that ALD offers starts to matter, and I do believe so. Thank you very much.
Thank you, Dr. Lee. Thank you very much for this very nice overview about ALD. I already see a couple of questions here in the chat box. Either you or any of your colleagues can respond directly in the chat box. So that I would like to move on to the next presentation.
Okay.